Hello, everyone, and welcome to this webinar on monitoring ML model performance on AWS with nannyML Cloud. I'm your host, Wiljan. I'm one of the co-founders of nannyML, and the goal of this webinar is to set you up in such a way that after you can deploy nannyML Cloud yourself on a Amazon Kubernetes cluster, and you can instantly start monitoring your machine learning models in production. But in order to achieve that goal, I will have to walk you through a few things. First thing, of course, is how to launch nannyML on AWS. Then you need to know how to add a model via the UI. And the first model that we are going to add is a model without target data in production. But that's, of course, using the UI, that's not the preferred way of how to do continuous monitoring in production. So I will also introduce you to our Python SDK, where you programmatically can configure and add models. And there we're going to be monitoring the same model, but with target data available.
Hi, I'm Michael, a senior software engineer for nannyML, and I'll be showing you how to deploy nannyML Cloud on AWS. I'm going to start off at the nannyML webpage, so you can easily follow along from there. And first off, we're going to want to go to nannyML Cloud documentation, and then since we're deploying on AWS, we'll go to the AWS page on the left here. And nannyML Cloud is distributed using AWS Marketplace. We have two offers available there. One is the nannyML Cloud trial, which is a 30-day free product that you can use to test out all of nannyML Cloud's features and see if it works for you. And then we also have nannyML Cloud, which is a paid product that you can use indefinitely as long as you purchase a license. From a feature perspective, these are equivalent, but for the purpose of this walkthrough, I'll be using the trial. So I'll open that up and then jump back to the documentation page to see exactly what we should be doing. So first of all, we are going to need some prerequisites to be able to deploy nannyML Cloud within your AWS account. So first things first, we're going to need a few tools to actually configure a Kubernetes cluster, because nannyML Cloud runs within Kubernetes within your account. So I want to stress that it's completely within your environment. No data will leave your environment, and these instructions are just to set up everything within your AWS VPC. So we're going to need a few tools, and we have some instructions available here to make it easy for you to get started. Because we don't want to force you to install everything locally, we can use AWS Cloud Shell. I'll open that up here. I have to sign in, and then, okay, I actually get redirected, and I can access the Cloud Shell from here. Then we have this command available to install Helm and EKS Control, which are two tools that are not installed in AWS Cloud Shell by default, but which we will need to actually deploy nannyML Cloud. So I'll jump back to my terminal here. Make sure you are deploying to the correct region where you want to run nannyML Cloud. In my case, I am using EU Central 1. I'll copy paste the commands that I copied. All right, there we go. Both tools are installed and should be available now. Then I'll go back to the instructions, and the next step, we have the tools, but now we need to set up a Kubernetes cluster. This is where nannyML Cloud will run, and we have some instructions available here that make it easy to do this. If you have an existing Kubernetes cluster or you want to make specific settings, you are free to do so. This is just an easy way to actually configure the cluster, which I will use for the purpose of this walkthrough. So first of all, the instructions here to install EKS Control. We actually have already done that, so I'll skip this step, and then we get to define what do we want to name our cluster. The default here is specified as nannyML Cloud Demo. That's okay for me. So I'll just paste this in. And then from there, we have a command to actually create the cluster and set it up with all of the necessary prerequisites. So I'll copy paste this command, paste it into my terminal, confirm using enter, and then AWS is spinning up everything for us. This process can take around 15 minutes. It's quite variable depending on available AWS resources and probably also the region that you're provisioning to. So we're going to skip ahead to the next part, but keep in mind this can take a while to actually complete. All right, I've just finished setting up the cluster. As we can see here, everything was successful. And we can go back to the instructions to go to the next step. Going to the AWS page here, we've now gotten all of the prerequisites ready to go. So we have all the tools installed. We have an Amazon EKS cluster set up with an elastic block storage driver to ensure that the data is persistent. And then from here, we'll want to subscribe to the Marketplace offer. So the nannyML Cloud trial, I'll go to the page and we can click continue to subscribe. We have to accept the terms here. It's a free offer in this case, so there's no price. I'll accept the terms, feel free to read through them. Of course, this could take 1-2 minutes for AWS to actually give us access to the software. Meanwhile, I'm going to take a look at the documentation here because the process is a little different if you were to go for the paid offer. Because when you actually buy nannyML, you have to configure which type of license you want. And this is explained here in the documentation. But essentially, what you'll be doing is configuring which type of licenses you want. So we offer 3 tiers. You can always check our website for more information about exactly what is included. And then for each tier, you just specify the quantity that you want to purchase. And each license will essentially allow you to run one instance of nannyML Cloud. So let's say you have multiple data science teams and you want to completely separate those environments. You can do that. You can, of course, also opt to combine everything in one instance. And I had a little pop-up here that I accepted the nannyML Cloud trial offer. So that means I should be able to go back to the page here. The offer is now been subscribed to, and I can continue to configuration. What we're really looking for here is only the software version. So these are the software versions that are currently available. We want to make a mental note of which version we want to deploy. We recommend going with the latest and greatest to have the best experience and all the features. And we'll need this version number later on when actually deployed. So I'll go back to the instructions here. We've prepared our license using the trial. So actually the paid instructions are not relevant for me right now. And I've already identified the software version that I want to use, which is 0.11.0 in our case. And now we can move on to actually launching the software, running and installing everything on the Kubernetes cluster. So first of all, we need to create access role to allow nannyML Cloud, actually the Kubernetes cluster, or nannyML Cloud within the Kubernetes cluster to communicate with AWS License Manager, and this will ensure that nannyML Cloud can use the trial license. So first, I have to, again, define the cluster name, and then I can copy-paste the commands to create a EM role that will allow the cluster to communicate with AWS License Manager. Again, I have to confirm because it's a multi-line instruction. And this takes usually around a minute. So I'll already take a look at the next step in the documentation, which will be downloading the nannyML Cloud helm chart. If you're not familiar with Kubernetes, this might not mean much, but the helm chart is essentially a description of what images are required for the Kubernetes cluster to execute nannyML Cloud. So download the helm chart first, and then in step 3, we'll deploy that helm chart onto the cluster that we created earlier. So first of all, we will have to define the software version, which is 0.11.0 here. So the instructions are up to date. I'll copy paste the command. Yes. And then the actual download command. Again, paste, confirm again using enter. Okay, we've logged in successfully and we have downloaded the helm chart that we needed. All right, then we can move on to actually deploying the software onto the Kubernetes cluster. Here, again, we can define something, first of all, which is where you want to make the application available. nannyML Cloud is browser-based, so you can define a custom domain that is applicable for your use case, your team. If you leave it empty, then we will use a dynamic URL that is generated by AWS. So that is what I will do in this case. I'll just leave it empty. But you can choose to use nannyml.mycompany.com, whatever makes sense for you. If you define a host name, you will need to configure appropriate DNS records, which is something that you'll have to do on your site in your DNS environment with your DNS provider. And then I can paste the command here to actually install the nannyML Cloud helm charts onto the cluster. This process again takes a few minutes, as described here. And once that is completed, the software will be active and we will be able to accept the trial license that was generated for us when the software started. So once again, I'll get back to you in a few minutes. Right, so after a few minutes, we can see here that the command has completed successfully. Status is deployed, so nannyML Cloud should now be active on my cluster. And I can go back to the instructions to continue with the trial license. So first thing that we have to do, which is specific to the trial offer, is accept the license. Because when the software first starts, it will detect that no license is available for your account, and it will issue a license that is valid for 30 days. But AWS requires that you accept this license. So I'm going to highlight this license here, select it. It's pending acceptance. Actually, I need to open the license, and then on the top right here, I can accept and activate. And AWS requires you to be explicit about these things. So accept and activate, you'll have to type in, confirm using the button, and now the license is available, which means the software should now have a license and it should automatically start. So we'll go back to the documentation and see how we can actually access our newly provisioned nannyML Cloud instance. For this, we have a command available here, which will show you the load balancer URL where the application is hosted. In my case, I did not configure a custom URL, which means this will be the only URL where the application is available. If you chose to specify a DNS name, then you would be able to also create a CNAME record right now, which is mentioned here on the bottom, allowing you to essentially create an alias under the URL that you want and link it to your specific NML Cloud instance. But for now, let me copy paste this command. I will run it in this Cloud Shell, and confirming, and then it should tell me exactly which URL my nannyML Cloud instance is available at. And then if I open a new tab, and I'll paste this in here. Okay, I am getting a warning here. This is because I am using a dynamic URL, and these URLs are ephemeral, which means we cannot really get a valid certificate for them, and we are using a self-signed certificate. If you were to use a custom URL, then this would not be an issue. It's specifically because we are using a dynamic URL. So for the purpose of demonstration, I am going to continue here, proceed to this access point because I know that it's actually safe and my browser is just warning me to make sure I know what I'm doing. So I'll continue here, and I'm faced with this message which says we couldn't connect your nannyML Cloud instance. Now, the most likely cause for this is that the server is still starting up, because every time the server starts, or when the software boots actually, we check is there a license available, and if not, then the software will shut down and Kubernetes will actually then reboot the software and periodically try again. So this means if there's no license available, the software will exit and it will continue to try again until a license actually becomes available. But this process takes a little bit of time. So hopefully if we refresh, we will be able to get to our instance. And I'm actually going to check what is going on here to make sure that our license is available. So if I go back to AWS License Manager, I can look at the granted licenses. I can see here that the license is actually active. And if I open this license, you can see here that we have a scale license for one instance, which is currently not used. So that would mean that the software is not active at the moment. And once the software has actually started, we would see this number increase. And in this specific case for the trial license, it would actually be maxed out since we only have one license available. So I'm going to refresh here, and it should be showing up any moment. It might just be a matter of waiting a little bit, but it is rather annoying. So actually, what you could do now is check the logs for the Kubernetes cluster to figure out what is going on. For example, okay, you can use kube control to get information about your cluster, and you have to specify the appropriate namespace, which in this case would be NML Cloud. Yes, and we can see here that our server has actually stopped, and it was last restarted 5 minutes ago. So we actually need to wait for it to restart again before the software will become available. And we can normally do that manually, but I'm not entirely sure what the command is. So let me actually see the documentation here. Yes, the way Kubernetes works is you would delete the pod, and then Kubernetes will automatically recreate it. So I can copy paste the name of the pod here, copy, paste. First, I'm gonna double check. Okay. This software is now actually already available without me having to do anything. So it's just a matter of having some patience. And then once you are inside the application, you'll be presented with a welcome screen where you can configure some additional settings of how you want to use nannyML Cloud, starting with authentication. Here you can configure how do you want users to actually log in to nannyML Cloud. We have three options available. One is that it's public, anyone can use it, or you can define a list of usernames and passwords and only grant those specific users access, or you can opt to go for OIDC authentication and integrate with your identity provider. Right now, if I select this option, you'll see here that we specifically have an option for Azure and Microsoft authentication with Active Directory. You can also use other identity providers using the custom tab. But this is a process or an implementation which we know can create problems because different providers handle the OIDC protocol a little differently. So feel free to try it out if you're using a provider other than Microsoft. If you run into problems, let us know and we'll try and help you out with that. Yes, and once everything is done, you can test authentication and it should confirm whether it's successful or not. In this case, okay, I left all the fields empty, so obviously authentication fails. But for testing now, I will go with no authentication. Then you can configure email notifications. Again, we have a few options. You can either disable notifications completely. You can opt to use an email provider offered by nannyML, which means you don't have to do any setup. It's very easy, but it's not the most secure because there's a third party involved. And if you want a fully secure setup, then you can use SMTP and connect to your own email server. Again, for demo purposes, I'm going to just go with the SaaS to have an easy experience. And then finally here, you can configure webhooks, which allows you to integrate with external software. Either you just disable webhooks completely, or you can specify a custom webhook, a specific address where you want to receive notifications every time nannyML completes a processing analysis or processing run. You will receive a report of which model has been analyzed and what the results were. And then moving on from there, I can choose here whether I want to collect usage statistics or not. Obviously, we'd appreciate it if you enable this because it allows us to improve our software. We are not collecting any sensitive data. We are just getting informed about what features of the product you are actually using. And it seems in the webhooks page here, I didn't actually complete it. So for now, I will just disable, next, and then finish. From here, my nannyML Cloud is completely set up and configured correctly, and I would be able to create my first model.
We're going to add a binary classification, and we're going to pick our main performance metric, just accuracy. We're going to chunk our results monthly, so the aggregation is going to happen monthly. And this is the hotel booking data set, which is a Kaggle data set. I'm going to upload it via AWS S3. And then I have to go back here to my S3 because I have to be fetching its location. And we need the hotel booking one. Copy the S3 URL. And then we can paint that paste that there. And this is the reference data. So in order for us to do successfully model monitoring, we have to establish a reference period where nannyML will look at, establish a baseline. This is typically a golden data set like the test set, where we know that the model is behaving as expected. And then nannyML will read in some of that data, and then we actually can configure this data set for nannyML. For instance, here, because this is the hotel booking data set, we'll have to define a target. And this is whether a customer actually has canceled or will cancel his booking, because that's what we're going to be predicting here. And then we're going to also identify an index. This is important later, because whether a customer will cancel their booking is an event in the future. And for this use case, we don't have instant target data and it will be delayed. But later, when the actual outcome becomes available and we know whether the customer end up canceling their booking, we want to connect the target data back to the predictions and to the specific customer. nannyML also here extracts some of the features automatically, whether it's a categorical or continuous. And after we've uploaded the reference, we're going to be uploading the analysis data set. And this is the production data that we're actually interested in analyzing. And because we don't have targets data yet, I'm just going to continue with our targets and start monitoring. And now nannyML is going to crunch a bunch of numbers for us. And while we're waiting for this, we can see that here's the new model. While we're waiting for this specific model to be finished, we can have a look at the other machine learning models, and I can explain a little bit how this model overview works. At nannyML, we always focus on a single performance metric, which we call the main performance metric. And we do that because typically when we have realized performance or when we have instant target data, we can measure the real performance, but in some use cases, the target data is delayed, and then we cannot measure, you cannot actually measure the real performance, but you can estimate it. And this is very powerful because that means that we actually always can get a view on performance. And that is the first thing that we do. And then we can actually also define some other performance metrics that might be of interest. And only when there's an issue with the main performance metric, we are going to delve in deeper into the root cause analysis tools that we offer. We have concept shift detection, covariate shift detection, and data quality detection. And for instance, here we can see actually the main value proposition of nannyML, which is that in all of these use cases, there is actually lots of covariate shift happening, but there are no performance issues. And because we can estimate performance and we can always get a view on the main performance metric, we would not have to delve in these use cases because this covariate shift that has been detected here has actually not impacted the model performance. And that happens because sometimes unimportant features drift, or there is drift to certain regions, and the model actually can deal with that covariate shift pretty well. I'll quickly have a look whether in the meantime the hotel booking data set has been totally processed, and it has. And this is our summary overview, which basically contains all of the insights from the performance and then the different root cause analysis tools that we have, like concept shift, covariate shift, and data quality. And we can see here on our main metric, which is accuracy, and also estimated because we don't have target data. So here's the data in production, and we can see that in the past 3 months, this accuracy has deteriorated and our model performance has gone down. And we know that because we have some red dots here, which are alerts. And it is comparatively to this reference data that we can actually draw this conclusion. We can see here that these thresholds, they are derived from the test set performance, and this would actually have been the expected performance in production based on what we saw on the test set, but that's not the case. In this summary overview, we can also get a view on maybe concept shift detection, or here the multivariate data drift detection. We can also add other features that we consider very important, and that we say, okay, if there is drift in this feature, then we're also going to be considering that as an important alert. And then, of course, we can delve deeper, and that's what this pane is for. This represents our monitoring workflow, where we start with performance first and then use all of the other detection techniques as a root cause analysis tool. So here we're going to be looking at performance. And we were looking at accuracy. And another thing that actually nannyML offers, which might be interesting for this specific use case, is to connect the actual predictions to the impact it has, meaning the monetary impact. And if we go to model settings, under performance, we can see here the business value, and here we can actually define a cost-benefit matrix where we can say, this is how much money a true positive brings in, and this is how much money we lose with predicting a false positive. And that way we can connect that to our estimated performance, and we can get an idea of the estimated impact that our performance will have in terms of monetary value. And we can see that here in this month, it will also already be considered a significant drop in impact compared to the reference period. So we see that there is indeed some performance issues. And then the next step would be to delve in deeper and to go and figure out, why is this happening? We cannot run, unfortunately, we cannot run concept shift, because for concept shift, we need target data. So we're going to delve straight into our covariate shift analysis. And we can see indeed here, just like we saw in the summary, that there is a problem with multivariate data drift detection. Here on the left side, we can pick all of our distance measures or statistical measures or some summary statistics that we might want to look in deeper. And then these are available, of course, for the target data if that's there, but also for our model outputs, the categorical features, and the continuous features. And this is quite feature heavy. So what we want to do during this analysis is probably to drill down some of the verbosity with some of these filters here, where we can say, okay, only alerts for the main performance metric, or only alerts in the last chunk. And I'm going to pick here actually Wasserstein distance, and then I can go and delve and say, okay, I want only the alerts in the last chunk, and then I will already have narrowed down some of my features where there's actually real problems. For instance, this feature shows actually alerts during the entire production period, so I'm not gonna delve in this feature too much, because this probably might actually be some training serving skew, because there were already some problems with this feature when the performance was still okay. But these features like the lead time and whether it is a repeated guest, and also here the average daily rate of the bookings, we can see that there is some alerts there as well. But for that, if we want to delve deeper, we can look at the distribution and see how those changed. And we can see, for instance, here that for the average daily rate in these last 2 months, the distribution has compressed a little bit, and also for repeated guests and the lead time, and also for the stays in 9 weeks, we can see that there was some significant drift. We can also have a look actually at the summary statistics here. And what we can then see is that actually the average lead time went down during this period, and there is more repeated guests. And of course, because of those two features, that actually led to the probability of people canceling their bookings going significantly up, and our models making more mistakes. And it's by piecing these pieces together that we can actually draw a conclusion of what has actually gone wrong. There's another detection root cause analysis tab that we provide, which is data quality. And here, for instance, we can see the target is, of course, missing in production, but also for country, we see that there are some unseen values in production. They're very small, so this is probably actually not a contributing factor to our performance dropping. But for instance, for agents, we see way more unseen values, so that might actually be problematic. We can also have a quick look at missing values, and then alerts in the last chunk. And then we can see actually that it's only the target data that is missing. I can show you how to add a new model, but instead of using the UI, I can use the Cloud SDK. And this is typically how we would be interacting with nannyML in production, is that we would use our Python SDK and not necessarily the UI. And to connect to this instance, I need to fetch the URL and I need to create a token. Voila, and then I can copy this and paste it here. And then I'm quickly actually gonna do the same thing that we did earlier, which is called retroactive monitoring, where we basically look at data from the past. And I'm gonna be uploading here the exact same data, except right now I'm also fetching the target data. And then I'm gonna be configuring the schema again, where I have to set the index and what the target column is. And then I'm gonna be creating the model. And this is gonna be sent straight to nannyML. And we can see that there's a new model being added, which I added from the SDK because I gave it this name here. And while this is running and completing, I can actually explain how we would do continuous monitoring. Because with continuous monitoring, we already have a model being set up. So for instance, for this use case, if there was new data or new predictions to be generated, we would get this model and then get its idea and then actually send the new features and the model outputs, the new inferences to nannyML. So we would be sending either data like this, where it's an entire batch, or every time we make a new prediction. And when we make a new prediction, we of course can decide to trigger a new monitoring run after we have fetched it. But since in nannyML we have to be aggregating monitoring results in batches or chunks of data, adding one single observation probably will not be impacting our results that much. But this is a step closer to real-time monitoring. But most of the case, you would probably not want to trigger a monitoring run ideally straight after one observation, but maybe if you collect hundreds or after 1 hour of making predictions, it might become interesting again. And then when the target data becomes available, we can do the same thing where we add the target data later, and where it is important that, of course, this target data contains the target, but also the index or an identifier, so it can be connected to the model again. And let me come back to this instance and then see whether this in the meantime has run. And here we can see that it indeed completed. And we can see that right now for the main performance metric, we also have the realized performance because we have target data, and which appears here in this performance view. But actually what we should do is here compare both. And then we can actually see that the predictions or the estimations that we were making for the model performance in production in the previous use case were pretty accurate because we can see here that the realized performance indeed has dropped. And since right now we also have some more target data, we can have a look at concept shift detection as well. I'm gonna express it in terms of accuracy. And we can see that in this entire period, actually, in production, there was no concept shift, and that the concept actually follows the same volatility that it had during the testing period. And this is also one of the new algorithms that we offer in NML Cloud. And how this algorithm works actually is that it's called reverse concept shift detection. And it takes the chunk of data in production and it fits a new model, and then it uses the representation or the concept of that model to make predictions or to estimate performance on the reference data. And that's why it is reversed, because normally we fit on reference and we make estimations on analysis, but now we do it the other way around. And we do that for every single chunk. And that's what we get here, which is basically the holdout performance of this chunk on the reference data, and we have that over time. And that's how we can actually draw the conclusion that here there was no concept shift, which actually also explains why it is this algorithm is working so well because MCBPE works almost perfect when it's just isolation of covariate shift and the impact of that on performance. Okay, and that has completed the walkthrough for the cloud product here. Thank you everyone for attending, and I hope this was helpful so that you yourself can also deploy nannyML and use the free trial and push the application to its limits and start monitoring your models in production. Thank you very much. Bye-bye.